8a, we have the sketch represents the graphs of the functions f of x, which is it's a quadratic formula or quadratic graph, and g of x, which is an exponential graph. The x-intercepts of f are a and b as given over here, and the y-intercept of f is 0 and 6. So we're given the coordinates for the x-intercepts of f and the y-intercept of f. The graph of g passes to the origin and the point 1 as to 2. So the graph of g, which is our exponential function, passes through the origin and the point 1 as to 2. Use the graph to determine the values of x, where the gradient of f multiplied by the y value of g will be less than 0, which means it will be a negative number. So this will happen when we have to look at the cases in which multiplying these two values will give us a negative. So since we have the first derivative of x multiplied by the y value of g should give us a negative number, we need to look at where this can arise from. So this can happen when this is positive and when this is negative, or when this is negative and when this is positive, right? Remember, this is the gradient. So when the gradient of f is positive, we want the value of g to be negative. Basically, we want it to be underneath the x-axis. So I'm going to zoom in a bit on our sketch so that we can clearly define the values at which these changes happen. So for my graph of f, it's a quadratic. Basically here it's going up, so it means it has a positive gradient, and here it's going down, which means it has a negative gradient. So this is a point that's definitely worth considering, because this is where a change occurs. Then for the graph of g, we can see that its change occurs at the origin, or at the y-axis, line, because that's the point where it goes from being negative to positive. So there are three regions in which we should consider. We should consider this region, we should consider the region in between here, and we should consider the region outside over here. So in this first one, we see the gradient of f is positive, and we also see that the graph of g is below the x-axis, so it's negative. So everywhere that is less than the turning point of this function is a point where our graph is going to be, or is a point where this condition is satisfied. And we do know what we can figure out what the turning point is, basically, because we know the value of b here is 1 and here it is -3. So in between 1 and -3, we need to find the midpoint. That will be minus, you add up the 2, which give you -2 divided by 2 to get -1. So -1 will be the midpoint here, and will be the value of the turning point. So basically we're saying this condition is satisfied when x is less than -1. But let's actually see what other values could possibly work. So in between here, we still have our g being negative. So between the red and the green, g is still negative, but it is on the verge of becoming positive, but it's still negative. But now this graph is also now negative on that part. It's no longer increasing, it's now negative for the rest of time, or for the rest of the x values. So negative and negative gives us positive, so we are not looking at this region. Then after, we see that this one now, the g is now above the x-axis, so now this y values are now positive, but the gradient of our graph is still negative because it's decreasing. So we can see when this graph goes positive, this one is still negative, and that will remain so forever. So it means when x is greater than 0, our condition is also satisfied. Therefore, we can write our answers as when x is less than -1 and when x is greater than 0. or when this or when x is greater than 0, these conditions are satisfied.